Hey everybody, Ms. Teacher here. We're taking a look at lesson 2.5, which is on model fraction division. And it's important that we know that there are actually two types of division problems. There's one type where you find out how many or how much in each group, and in the other, you find out how many groups. So if we take a look at this next example here, we'll come back to that in just a second. So let's say we wanted to know how many 2/8 are in 6/8. All right, so I have on this number line, I have a green line that represents 6/8. Now this little red line happens to represent 2/8. So if I count how many of these do I have, see there's 1, this makes 2, and this makes 3. So the answer is 3. All right, so let's write that down. There's 3. All right, now when we think about what division equation does this represent, there's really two different ones. There's the idea of the dividend being 6/8. So we're taking 6/8 and we're asking ourselves, how many groups of 2/8 are there? And the answer, of course, would be 3. And then there's the idea, this is 3 groups of 2/8. And then there's the idea of the other type of division. So let's go back and make sure we understand the two different types of divisions. There's one type, how many groups are there? And then the other type is how many in each group. So quantitative division or partitive division, right? So if we identify the dividend, that's the thing that you're starting out that's going to be broken up into groups. So the dividend is always that thing that's being broken up into groups. But really, these two things, the divisor and the quotient, are really, in a way, kind of interchangeable. So what do I mean by that? If we take 6/8 and we want to know how many, if we have 3 groups, how much in each group, we would come up with the 2/8. So both of these division equations are true, and they both can be represented with this model. All right, so let's take a look at another example. When using a number line to model a fraction or mixed number division problem, you'll need a common denominator. If using the standard algorithm, common denominators are not necessary. So if we take a look at this number line here, so let's just come up with a value here, and we want to know, how about, let's have the value be 20/12. All right, so that's the thing that we're starting out with. We're starting out with 20/12. Now, if we want to know how many groups of, let's say, 1/6 are in 20/12, it's a good idea to rethink this as something 12ths. So if we rethink that as something 12ths, we would realize that that's really equal to 2/12. So if we're taking this idea of 20/12, that's unsimplified, by the way, and we want to know how many groups of 1/6, which is also equal to 2/12, let's use the number line to figure out the answer. All right, so let's use a different color, by the way. All right, so here's one group of 2/12 right there. There's 1. This makes 2. Here's 3, 4, 5, 6, 7, 8, 9, 10. So the answer is 10. We have 10 groups of 2/12. Now, we can also talk about this model that we have here on the screen. We can also talk about the dividend still being 20/12. So let me write that in another way, 20/12. Which, by the way, anytime you have mixed numbers, you always want to turn them into improper fractions anytime you're going to work with them. So if we had the 20/12 and we wanted to break that up into 10 groups, so our 10 groups are in the 10 little circles, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we wanted to know how much in each group, then we would count how much in each group, and we would get the 2/12, which of course would be equal to 1/6. Now, if we talk about the standard algorithm for this, let's just take a look at that real quick. I'm going to erase this one just so we have room. If we do the standard algorithm for division, the first step is to turn any mixed or whole numbers into improper fractions. So this already is an improper fraction. The second step is to multiply by the reciprocal of the divisor. So if we rewrite the 20/12 and we rethink this as the reciprocal of the divisor, if we flip this around, the reciprocal of this would be 12 halves. So we're just showing you that the answer is indeed 10 by doing the standard algorithm. Now, if we proceed with the rules for multiplying, right? We reduce, divide by 2 and get 1, divide by 2 and get 10, or here, 12 is a factor of both of these, so divide by 12 and get 1, divide by 12 and get 1. And if we do the math, 10 times 1 is 10, 1 times 1 is 1, and 10 divided by 1 is 10. So the algorithm matches the picture. Let's take a look at another example. Let's find one that's already ready to go. All right, so here's one. How many groups of 3/16 are in 12/16? So we have traced here in green 12/16. And if we count the groups of 3/16, see here's a group of 3/16. There's 1, 2, 3/16 right here. Here's another group, here's another group, and here's another group. So we can visually see that the answer is that we have 4 groups. But what would that look like as a division equation? So if we take a look at it as a division equation, remember 12/16, if we simplify that and divide this by 4, we get 3. Divide this by 4, we get 3/4. So 3/4 is equal to 12/16. And if we're breaking up that into groups of 3/16, and we did the algorithm, because remember, we already know the answer is 4 because we can see it, we would multiply by the reciprocal of the divisor. So that would be the 16/3. And if we took advantage of the idea of reducing ahead of time, divide this by 4 and get 1, divide this by 4 and get 4, and then going this way, divide both of these by 3, we would get 1 times 4 is 4, 1 times 1 is 1, 4 divided by 1 is 4. So we still get the 1. Now, something to keep in mind is that we can also talk about the fact that we have 4 groups. But if we took that same value of 3/4 and said, let's figure out how much in each group, right? We could, these are interchangeable. We could do 12/16 and divide that by 4. And we know the answer would have to be this value right here, the 3/16, because that's the same idea as saying, if you have 12/16 and you break it up into 4 groups, how much is in each group? And the answer would be 3/16. So that idea, what's confusing about division is you have the 2 different kinds of division. And let me bring that up again. There's the kind where we're talking about how many groups. And then there's the kind where we're figuring out how many in each group. So that's important that you understand that, because there's a definite relationship between, these are actually interchangeable, and you could use the same dividend and swap these out, and you would have an equation that would be true if you swap the divisor and the quotient out. All right, so let's take a look at another example. Find a good one here. I already have. All right, so actually, let's look at this one. All right, so we're looking at what number sentence is modeled below. Now, the first thing you want to figure out is what is the thing that's being broken up into equal groups. So the green line represents the thing that's being broken up into equal groups, and we have to think of an equivalent of that. So if we just look at the improper fraction equivalent, that's 28/12, but we could talk about that as 2 and a little more, right, by doing 28 divided by 12 and getting the mixed number equivalent. But probably just so our brains can wrap itself around it, we're going to think that as 28/12. Now, we can talk about the fact that we're breaking up. We want to find out how many groups of 4/12. So see, here's a group of 4/12. See, 1, 2, 3, 4/12 right there. Here's another group. Here's another, and another. So if we count up the blue circles or groups of 4/12, we get 7. Now, another way we could think of this is we could also think of this as 28/12. We wanted to know if we have 7 groups, how much in each group? The answer would be 4/12. So you can also argue that another equation that's represented by this model is 28/12 divided by 7 equals 4/12. All right, now if we were to do the standard algorithm and simplify stuff, like this is equal to 7/3, right? If we divide this by 4, we get 7. If we divide this by 4, we get 3. And if we were to simplify this, that's equal to 1/3. Now, if we looked at it as an improper fraction, right, 7/3 is equal to 2 1/3, we would kind of go back to this idea of using the simplified version, and we would change, so let me just box this in. We would multiply by the reciprocal of the divisor. So what's the reciprocal of that? It's 3 over 1. We would keep this, change this to multiply, and flip this to 3. So if we did 7/3 times 3, which is the same as 3 over 1, by the way, you can see here that the 3's cancel out, and we're left with 7, which we can see the model shows us that there are 1, 2, 3, 4, 5, 6, 7 in the group. All right, so it's very important you understand how to model any type of division equation. If you are asked to model a division equation and they present it to you like this or some other way, then you want to rename the things with common denominators and then model it on the number line. All right, I think we have time to maybe look at one more example. Let's see if we have one here. All right, so if we look at this example, how many 1/4 cup servings of raisins are in 3/8 of a cup? Now, if we talk about 3/8 as being the dividend, that's the thing that we're trying to break up into groups. You can see here that if we find a group of 1/4, which by the way is equal to 2/8, so here's your one group of 1/4. We have one full group. But when we look here, we don't quite have enough for that second full group. So the answer is that we have 1.5 groups of 1/4, right? Now, if we did the algorithm for that, and we did 3/8 divided by 1/4, that's the same thing as 3/8 times the reciprocal of 1/4, which would be 4 over 1. And if we went ahead and took advantage of the reducing opportunity here and did 3 times 1 and got 3, 2 times 1 and got 2, and rename that as a mixed number, we would get 1.5. And you can see we have 1.5 groups of 1/4. So that one's a little bit tricky because this is a partial group, and that can make it a little bit confusing. All right, so this question, it says the model below represents a division problem. Which equation is represented by the model? Now, the first thing you should do is figure out what's the amount that we're starting out with. So we have, if we take a look, we have this chunk, right? And then we have this chunk, and then we have this chunk. So what would represent that? So we have 1, 2, and 1/3, right? So 2 and 1/3 would be the thing that we're breaking up into smaller groups. So that means that this one's probably not going to be right, this one. And then this one's not going to be right. So these are kind of off the table as contenders. So if we're starting out with 2 and 1/3, we have to figure out how is it being broken up into groups of what? So if we look kind of carefully here, it looks like they're talking about groups of 2/3. So here's a group of 2/3. Here's another group of 2/3. Here's another group of 2/3. And then we're kind of shy that 1, 2, 3, and a little more. It's not quite 4 groups, right? So is the answer, do we have 3.5 groups of 2/3? Or is it this? So which one is modeled by this? Now, what you might want to do is actually do the algorithm for each of these to see which one is true and matches the picture to help you narrow down between A and B. All right, so I think that's a pretty good head start for how to do these types of problems. Hopefully you found this video helpful.